Right. We can actually dive into the session. First of all, I would like to have, even though we are doing this, kind of what do you call the remote session, I would like to have it as interactive as possible that we can. So if anyone wants to have kind of questions in between, feel free to interrupt and then unmute yourself and you can ask a question. So, right. First of all, I mean, when I got this topic for today, I checked with what are the things that I need to cover in this section. So these are the things that was asked to cover in this lecture. So the first one was the soft skill and technical skills that are required to be a software engineer, and what kind of things that actually industry is looking for from the fresh graduates, that passing out from the university. So in that case, we can talk about market-driven technologies like cutting edge, like very latest technologies, and what are the related information around that, right? So and then the other topic was branches of software development. That means what sort of area that you will be playing your role as a software engineer, whether it is a you will be basically implementing web applications or kind of a mobile applications or kind of a security applications or any game development, something like that. So what are the branches available or kind of areas available in software industry? So that was one of the other things that was asked. And types of careers in software development, that is like even let's say for example, if you want to be a web application developer, which part you will be working on, like whether you will be a front end engineer or a back end engineer or kind of a full stack engineer where you will be focus in both parts, or kind of a DevOps engineer or a security network, anything. So what kind of a career is available in the software industry? So that was the one of the other things. And then prerequisites to join the industry as an intern. So I hope this target group, I'm not sure whether someone is there, like have already completed the internship and trying to join the industry as a fresh, like as for your permanent job, or an internship, like maybe once you complete your third year, assume you guys are now expecting an internship opportunity in the industry. So what sort of things that actually industry is looking for? It's not I'm not limiting that to what Wiley is looking for from an intern, but I would like to talk about in general, because I have interviewed so many candidates as an interns, and also job seekers. So what kind of things in general the industry is expecting from a fresh graduate? So I would like to talk about them as well. And then the career hierarchy, what we call in simple terms, like career ladder that you have in software engineering industry, right? So like in 2 years, who will you become? In 5 years, what can you do? Maybe in 10 years, what can you do? Something like that, right? So what is the career path available for you to grow? So these are the main topics actually I picked for this session. So based on these things, actually I came up with my outline for this session. I'll be talking about who is a software engineer, and then obviously the technical skills that is required, that are required for you to become a software engineer. And then, as I said, the branches, mainly the areas in the software development industry, and career types and soft skills. I'm actually thinking to spend some couple of more minutes on this section, because not limiting to technical skills, but nowadays we are seeing a lot of things regarding soft skills. I mean, the lack of soft skills mainly from the fresh graduates. I'll be mainly kind of focusing more on this area. And then, as I said, the internship prerequisites, what the industry is looking for from you, and then the career hierarchy finally. So yeah, who is a software engineer? So we can give it a start. I mean, you all, I'm probably you all have already an idea about what I mean, who will be a software engineer, and who that person is, what that person is doing in the industry once joined to a company, or they can start their own business as software engineers. They can start with their own applications, their own systems, products. But what and I mean, who and what will be doing? I mean, basically software engineering in the industry. So I have put some of the notes in these slides. I'm not planning to go through these notes. These are for, I mean, after this session, I can actually share this slide deck with you. So you can have this as a reference for you to, maybe, rethink about it and get some idea about it. But I would like to, kind of have a general discussion around these topics. So as mentioned in the slide as well, a software developer is a person who is concerned with different areas of software development process. That could be from researching, that could be from gathering the requirements, understand the requirements, translating requirements, and then maybe you will be dealing with technical designing, and then the implementation and the testing. That is a key part in the software industry. Like even though you implement anything, you have to make sure that that is up and running, and that is working in very functional that will have the right functional behavior in the production. So that means you have to test it, and then maybe after that you have to support it as well, because if something goes wrong in the production, once it is in the client's hand, if there's something going wrong, you will have to monitor it and provide the necessary support as well. So a software developer may take part in, as I said, design, computer programming, and or software project management as well. Like even though we call it software engineer, in in very early stages, we call them software developer or software engineer or maybe software analyst. But going forward in the same industry, they will be mastering their career, and then they will be growing up with experience, and then they will come to the project management side as well in terms of software. So it's not like kind of a project management that you see in other world, but it's basically it's very specific to software lifecycle management as a project. Yes, so it would be more easy and important to talk about like R&R, roles and responsibilities of a software engineer, so that you all get a good idea about what this particular person is doing in the industry. So as I said in the previous slide as well, from the requirement analysis, like from the gathering of the requirement, software engineer has a role to play, right? So it's not like when you say a software engineer or software developer, you are not just a person who is going there and coding, right? So but most of us have that idea, when someone says I'm a software developer or a programmer, I should go there and learn, I mean code, right? Not all the time, right? Because for you to code something, for you to develop something, you need to understand what you are going to develop. So in that case, that is the requirement actually. That is the client requirement. Let's say, for example, if you have a client and then client is coming and asking for some particular feature in a web application or a mobile application, you have to know what the exact requirement that the client wants, so that based on that you can come up with a proper technical design or architecture, and then on top of that you can start your coding. So of course the programmer is a role, and you have a coding responsibility with you, making sure that you are coding the right thing, and then your logics and business logics and functions are working fine. That's a part of it, but it is not limited to coding part. So as I mentioned in this slide as well, there are some other required implementation as well. Like say for example, if you have you are developing a mobile application, and then maybe there can be some website associated with that, and then you need to show some of the data, I mean fetch some of the data from the website into your mobile application and then display them, right? In that case, so there's some integration happening between the website and the mobile application. So there can be some like similar other implementation as well for your application, right? So like dependency installation, let's say for example, if your application to be run, there should be a particular operating system in your machine. So in that case, that could be one dependency, right? There can be some configuration associated with that, right? Let's say for example, if you are moving your application into cloud platform from your local machine, there can be some configurations associated with that, and some customization of course you have to do, right? As I said, the integration, like the example that I took for like mobile application to web or the vice versa. And there can be some data migrations as well, like data migration as in you can have some data already in your system, and then you are introducing a new feature or a new application, so that you have to make sure that the previous data is also available in your application. So data migration can also occur in this kind of situation. Of course, once you develop it, you have to test it, right? That is, we call it dev testing. So you have to be act as a tester. That is kind of a role that you have to play in this software engineering life cycle, right? So you have to make sure that what you code is working fine. If you identify any defects, any errors, or any bugs in between that, you have to fix them immediately. And then maybe if your application is talking to some other application, maybe interacting with some other applications, there should be integration testing happening in between, so that you can make sure that your application is also working, as well as the other applications are also working. And then we have another testing called regression testing. So software engineers sometimes get involved in regression testing as well. When we the meaning, I'm not sure you are familiar with this regression testing term, but the basic meaning of that is, when you implement something and when you push that to production, you need to make sure that whatever already there in the production is not broken, right? So that means, I mean, you can test whatever that you implemented, and then you can make sure that that is working fine. But at the same time, you have to make sure that whatever the existing applications in the production are also working fine along with your application or the new feature that you introduced. So that is what we call regression testing. So, and then most importantly, documentation. Like software engineer has a key role when it comes to documentation, because software engineer is the one who is involving in the entire life cycle from the beginning to the very end, right? That is production support and maintenance. In that case, software engineer should have to have that the clear idea, what are the decisions that we made, what are the things that we change in between, and how we actually decide, okay, this program language we should use for this, and we shouldn't use this kind of a language. So how was that decisions were made, something like that. So everything has to be documented in very clear and comprehensive manner, so that you can have that, you can refer it back later if there are some some new things to be added, or any issues coming in between. Let's say, for example, after 1 to 2 years, if you get some issues in the application that you built, which is running in the production now. So if you only have kind of a very comprehensive documentation, only you can refer it back and say that what has gone wrong. So those kind of responsibilities are very have a very the key roles when it comes to software engineering life cycle. Software engineer, actually, even though they are growing, and they are gathering a lot of experience, and they are gaining experience, and becoming kind of a senior level, but each of these the responsibilities and the roles associated with are a part of in your journey. Starting once after you started as maybe associate software engineer or a software engineer in next couple of months, so that will be your responsibilities in your journey. Yeah, so with that, I can actually move to the types of software engineers. But even in the previous slide, I talked about a little bit different types. But I mean, I have put them, as I said, in this slide as well. So you can be a software developer, or I mean, that is the very common the role that we are having, or the type we are having in the software industry. There can be specific people who are working with only the designing part, right? So we call them a designer or a front-end developer. I mean, front-end developer can be a designer or a developer, or designer and developer, right? There can be people who are only designing the UI, maybe the front end, but they are not actually developing the business logic into it, right? So this is someone having a question? All right. Okay. Now I got some voice. I thought someone wants to ask a question. But if someone wants to ask a question, you can interrupt me at any point. So yeah, I was talking about designers and front-end developers. Like as I said, there can be people who are doing the both, or one at a time. And of course, we have a back-end developers, like they are very focusing on the back-end part of the software. It could be a web application backend, or a mobile application backend, or a desktop application backend. But that would be that is where you are basically working it, right? And also nowadays, like very recently, a lot of them are actually are willing to take part of full stack developer arena, because that is where you will be a kind of engineer who knows, like, from start to end, right? Like yeah, if you take web application, for example, there can be front end developers, there can be back end developers, as well as there can be full stack developers who will be working with front end technologies, back end technologies, database technologies, integration techniques, and some infrastructure related technologies, everything. So that is where we meet full stack developers. And of course, once these software are in production, when the users are actually using it, we have to have software support engineers. They are not all the time, they're not involving in developing, but they actually supporting to the application if there's something going wrong, or if if a client comes up with a issue or error of the application, they are the ones who involving in troubleshooting it, identifying the root cause, what has gone wrong, and then identifying maybe any what do you call the any workarounds that you can apply just to make sure that the client is not blocked, and until the developers are actually coming and fixing that issue. So software support engineers are also there, and software quality assurance engineer. So those are the ones who actually before we actually push this application to the production, QA engineers are the one. Actually now we call them QE, that is quality engineers, not this quality assurance engineer is going kind of like actually the quality engineer, the QEs are getting more popular than quality assurance engineer, like we had in the earlier days. So they are the ones who's making sure that the application is up and running with the correct functionality, and whatever the business requirement are already met, right? So that is they actually assuring that part. And of course we have DevOps engineers. That is also kind of a new term that we got to hear very recently. Those are actually earlier days actually we had operations engineers, but now developers and operations are kind of we call it a different terms called SRE, like site reliability engineers. So DevOps is a kind of a new term. I mean, not like very recent, but kind of introduced kind of recently, where those are the people who will making sure that the infrastructure, the deployments, the continuous integration, continuous development, and everything is up to date, and the application is up and running with no issue. And of course we have security engineers who will be taking care of the security side of the application. Let's say for example, if you are maintaining a web application where you have for example let's say you are dealing with a lot of sensitive data, right? Let's say for example credit card transaction. So credit card kind of a data can be very sensitive to one person to another, right? So in that case we will have to have a lot of things in place in terms of making sure the security is actually the application is secured in the standards that world is having today. So in that case the security engineer will come into the play. And then network and systems engineers are also kind of a similar, but they have different roles. When it comes to a large organization where we have a couple of applications or kind of a very like large systems with like millions of users are using it, we'll have to make sure that all the time the systems are tolerant enough to have the provide the support to the users. I mean, let's say for example, if you take Facebook as an example, right? The number of users that are in the Facebook
Right.
today is kind of they don't have anything to I mean at least to have reference with, because they are having the massive number of, I mean the largest number of users in the system when it comes to social media right now. So in that case they can't actually refer back to something else and learn from that. They have to make sure their systems and network engineers have to make sure that all the infrastructure and every application running in their infrastructure are up to up to the standard, making sure that no user is getting blocked, or any issues are not going, right? So that is kind of a role that systems engineers are playing today, right? Especially, I mean, it is not one system engineer, but it's a team of people. They will have security engineers with them, they will have network engineers there with them, they will have DevOps engineers, everything. I mean, everyone actually working together in order to make sure that kind of system is up and running. So the other roles actually I have mentioned here, those are kind of those are not very related to software programmer or a developer, but at the same time a software engineer can be a business analyst as well, right? So, or a requirements engineer. So that is why actually I wanted to highlight in this area as well, because that is one of the very positive area that you all can target as well in the future. You I mean while you can while you can be a software engineer or a programmer, at the same time you can be a requirements engineer as well, right? Where you're translating the business requirements to engineering requirements, right? So not every business analyst can do that, because most of the business people understand only business requirement, right? But a software engineer or a software developer, when they know the code and when they know what is the underlying the logic and the functionality going on with this feature, then they can easily relate that to the business feature, and then they can translate it in a very nicer and very effective way. So that is where nowadays actually software engineers are playing these kind of roles as well. Of course, as I said in the previous example with Facebook, so system administrators, IT specialists, everyone are part of that like kind of a large kind of application suite or a platform. So again, I want to highlight about the project managers or the IT managers. As I said, similar with the business analyst field. So when a software engineer becomes a project manager for a software, that they have the ground level understanding about how software engineers work, how they estimate, how they calculate time, and how they actually make use of their time. So in that case, those project managers who are who are having, I'm not saying that any project manager can't do that, but many project managers can do that. But at the same time, if you are a software engineer and then you are moving to kind of a management track of the software field or IT field, then you will become kind of a more successful project manager, because you know the ground level and you know how they are functioning, right? So those are the there are some other things as well in this category, but I just wanted to highlight the very the main and basics types of software engineers. Any questions up to now, or we can move on? Looks like we can. So we can go to the technologies that you want to learn in this this section. Actually, I'm not targeting to explain you each and every technology is, because those are very readily available for everybody in the internet. You can search and learn. You can do your research. You can do your homework, and you can learn whatever things that you want to learn, right? So but in this section, what I wanted to highlight is this. So when we take one sort of area or one branch of a software engineering industry, so there can be a lot of technologies, right? There's a reason that I put all of these. Actually, this is not actually everything, but there are a lot of things other than this list as well. But I wanted to highlight here, you are not supposed to learn everything, right? To be a successful web application developer, you're not supposed to learn each and everything of this, right? Because someone actually can't do that, right? Because it's not, it is pointless. But at the same time, you can learn only PHP. I'm taking PHP as an example, and then you can be a very successful web application developer, because there can be times your client only asking web application, and then with PHP you can provide all the functionality that the client wants, right? In that case, the client is happy, and then you have done a very nice application, and then it has all the features that client wants. So you are still a web application developer, right? And then you are successful on that as well. So that is the point that I wanted to highlight here. And also that is the other reason that I added these kind of things, just to break that mindset that you are not supposed to learn everything. You can master one or two things out of this entire list, and then you can be still be a very successful web application developer, right? But when it comes to technologies and in web application development area, you will see a lot of things, right? Java EE, Spring Framework like JavaScript, Node.js, React, Angular. Those are very popular ones nowadays. PHP is kind of old. And then when it comes to .NET, like Microsoft, you have ASP.NET, C Sharp, MEC, everything. And then you have like Python kind of open source ones, Django framework, MySQL database, PostgreSQL, Ruby on Rails. There are a lot of technologies, right, when it comes to web application development. But as I highlighted earlier as well, what you need to understand here is, and also new technologies also can come tomorrow, right? Like there can be, there will be actually one technology can come tomorrow, and beating all of the performance that we can take out of these technologies, and that can be the master. But that is fine. At the same time, as long as your technology and your application is fulfilling your client's requirement, and then as long as if the client is asking more requirement, and you can fulfill them, you are good, right? So you don't need to learn everything. So similar with that, mobile application development, when it comes to mobile application, like where you are creating apps for smartphones or tablets, again like that, right? So a lot of new technologies, there are so much of things. But for example, if you want to be an iPhone developer, you can learn iOS, of course. Objective-C was the previous one. Now it's Swift. So something like that, right? And then if you want to be an Android developer, So now the latest one is the Kotlin. So earlier it was Android Java. So there are things. Now the BlackBerry and Windows Phone are not so popular, but earlier days those are the technologies. I've actually added these hybrid ones as well. React Native, Flutter. Those are very latest technologies when it comes to mobile application development, where you build hybrid applications. That means you build once, but that will compile and build application for the both the platforms like Android and iOS mainly, right? So that hybrid approach is also there, like React Native, Flutter. Cordova was kind of old, but React Native and Flutter are very latest. So that is the idea, right? So I have put them here just for you to refer it back and get an idea, like, okay, this technology is in which area this technology is useful for. But at the same time, I just need to again highlight that you are not supposed to learn everything, but you can master one or two things, and then still you can be a good mobile developer. So the same thing with server-side development as well. I'm not going to detail about this because it's the same, almost same thing. And when it comes to database development, also there are a lot of database technologies. Nowadays we have MongoDB, kind of a NoSQL thing. Earlier we have kind of a relational database, MySQL, SQL Server, and everything. So right now also some applications, even at Wiley here, we are using a couple of technologies to the same application, depending on the reasons. Or sometimes we actually on one technology, something like that, right? So that all depends on the requirement at that particular stage. And as long as I said, as long as your technology selection and your application can fulfill the current requirement at that point, you are good, right? So that is how actually, otherwise, when a new technology comes into the play, the old one should go away, right? But that is not happening because, otherwise, there are, we don't have, we actually won't have this kind of a technologies. If one comes, then the second one goes, right? So it's not the case, right? We every day, the new technologies will be coming, but at the same time, the old ones, the very popular or the very stable ones, will also stay. Right. Yeah. So game development is again another area, and there are some things that you need to master if you are willing to start some kind of a game development, like 3D graphics, OpenGL, C++, DirectX. Those are kind of a libraries and frameworks available for you to you know uh, do some like game engine kind of a thing. AI, artificial intelligence, anyway there. And networking right now, I've seen that most of the time, nowadays the mobile games and everything are very network based, right? So earlier we used to play just one player, but right now we can team up and then play, right? So the networking, AI, and everything are actually playing a big role there. And also social media games, right? I don't think I need to explain them because I'm pretty sure everybody in this session like have a social media account, and at some point they have maybe used kind of a social media games or apps, whatever. So those are very familiar for you all. And there's another area not many are interested in, but we have seen some people are interested in this area as well. Embedded system development, where you work with microcontrollers, kind of electronic things like Internet of Things. You integrate with your software and your hardware are getting connected. Let's say, for example, there are things that through a mobile app you should be able to control the room light, right? Or maybe your TV, or maybe your security camera or whatever, right? So that is where the Internet of Things come in, and then you will find out kind of embedded systems development. So that's also in one of the very leading industry now in software industry. So you all can, if someone is willing to take part of that and learn or do some research on that, you all can read about them as well. Right. The next section that I wanted to talk is soft skills. I think, yeah, we are on time. Right. So the soft skills, actually, I uh, I have actually put main things under the soft skill sections, for you all to get an idea on what sort of things that actually the industry is looking for from a fresh graduate as an intern or a fresh graduate, right? So the communication, communication is a must, right? So I have put it here in the first as the first thing under the soft skill section, because communication is not always the language, right? So you most of the software industry, the software companies, nowadays they are using business language as English, because they are working with foreign clients and all. But it is not always the language, right? So you can be a very fluent in language, but you can't you are not you cannot be a good communicator, right? Because it's not always. Some people actually, most of the time, I have seen that they think if they can't talk in English or whatever any other language, they think that they can't communicate. It is not like that, right? So you if you are very confident on, what, if you know what you want to say, like what message you want to pass it, you simply can use any language that you can, right? And even a broken English, or even whatever broken language that you are going to use, right? You can put whatever the terms and phrases, and you can pass the message, right? So that is the key part here. It is not mastering a language is some other thing, right? You have to do it, because if you are going to use English or whatever other language as a business language, then you have to master it. That is a different thing. But in any language, you should be able to communicate very effectively, right? So that is the part that I want to highlight here. And then empathy. So when you are actually working in a team, once you are join with the industry, when you are working in a team, you have to put yourself in other person's shoes, right? And then you should feel that, right? So it's not like you always, even though you are doing the right thing or wrong thing, it doesn't matter, right? Because when you are actually in a team, your decision making and everything has to be combined with others as well, right? So that is why actually I put these terms here. You all can refer it later as well. So being able to empathize with your team allows you to fully understand the problems that they face and find a way to make your project work for everyone. It is, as I said, it is not only like one person is doing it. It is basically a teamwork. So that is where the empathy comes in very handy. So of course, the third one, teamwork, these are actually going hand in hand. These soft skills are not like very different to each other, but I just wanted to highlight them in a manner, so that you can relate them to each other, and then see the importance of having it. So as I said, teamwork, I don't think for a university student, I don't think that I need to explain how teamwork is important when it comes to work in the industry. Because it's not like you even though you are a scientist or whoever, right? At the end of the day, you will have a team to work on, right? At least your leadership team, at least your organization team, or your client, or your subordinate, or your any peers, whoever, right? So in that case, teamwork is a must. You should practice it. You should know. How to collaborate with each other. It's not like you only doing your thing, but at the same time, you help each other, and then get the team's effort, more successful. So the confidence, as I said, I put things in line, but it's not an order, right? So most of them are very, very interconnected. So when it comes to confidence, obviously it takes some time to build the confidence, right? And also it is okay to make mistakes, but most importantly, you should learn from the mistakes, right? And then you should target not to do the same mistake again, right? So while making mistakes, be confident enough that you can find a solution, or at least approach the problem in several angles. So that when you have confidence only, confidence is actually building and growing over time. It takes time, as I said. But at the same time, you can be more confident if you are willing to learn from the mistakes, so that you won't do it the same mistake again. Right. Then the patience. Patience has a key role when it comes to software engineering, because I think, even my experience, what I have found out so far was, it is, the most hardest, person that you can be patient with is yourself, right? Because you are the one who's rushing it. You need to do it very fast. You don't have time for yourself, something like that, right? So in that case, like to practice and to overcome that challenge, what you need to do is give yourself enough time, right? And then enough chances to make errors and then fix them. As I said in the previous slide as well, you should be able to understand that you can do some mistakes, but you need to learn from the mistakes. and then give it a time, right? Don't rush for things, give it a time, and then see, how the patience is growing inside you. In that case, like as I said, once you are patient with yourself, it is very easy to be patient with other people. So that is one of the most the soft skills area that I wanted to highlight. These the first five soft skills that I mentioned here. And open mindedness and the adaptability, I think these are very, sorry, the text and everything, gives you the basic idea. I don't think that I need to, explain each and everything, but I just put them here for you all to refer it back, and also, you all to get an idea about okay, how actually these things, come in handy when it comes to a teamwork, when it comes when I'm working for a company with some team, and working towards a common goal, right? So I'm pretty sure that you have heard this term, stay hungry, stay foolish, from Steve Jobs. That means, you have to be always open for ideas, and and you have to accept, and you have to try out the other ideas. So even though they are completely different, right? So you can open for them, you can, analyze them, you can actually validate them. If needed, you can negotiate them those ideas with the persons as well. But only thing is, you have to be open to hear them, right? So that is the key take out from this thing. And then critical thinking, creativity, and problem solving. Actually, these are kind of what we call different things, but I wanted to put them together because those are going hand in hand, so that you all get the relationship between them, right? So the critical thinking, actually, I can actually talk about these things when it comes to the prerequisites for software. I mean the intern, that is a part of there. So but creativity and problem solving, we are actually looking for the basic problem solving skills from everybody. uh, so that that is where actually you can apply your critical thinking ability, and also your creativity, right? So you can read through these lines and then get the idea. But what I wanted to highlight here is, when approaching a new problem, always view it objectively, even if it's one you created accidentally, right? So that means then only actually you can think about the actually you can see the big picture, right? Out of the problem, right? So that you will see different angles, so that you can approach in a different way, and then eventually you can fix the problem, right? You can apply your creativity as well. I'm pretty sure that you guys are more creative than me. So because you guys are very freshers with very fresh minds, so you all have a very creative idea. So when it comes to problem solving, try to apply your creativity and critical thinking to understand the context of the problem, so that you can easily solve it out. And then time management is a key thing, right? It's again self-explanatory. Everybody understand here, as a third year or finally is a student in the university, how critical it is to when it comes to time management. So the same thing we expect from you in the industry as well, from software engineers. As developers, you must be time conscious. You should be able to justify why you need this much of time to complete this task. And at the same time, once you give an estimation, you should stick to that, right? And then you should commit it, and then you should try to complete within the time frame. So that is what is called time management, so that you don't have to worry about other things. You can focus on that, complete it given the time frame, and then you can enjoy your free time. If not, if you are failing to manage your time, I mean the work time for the work, then you will have to sacrifice your time for the your other things, right? So that is the most important area here. What you need to understand is you have to be very conscious on estimating, and and once you estimated, you have to stick, and you have to be very realistic on that. And the last thing I wanted to highlight here is accountability, humility, and humbleness. I think those are very, very common terms that everybody are familiar with. But I just wanted to add it to here as well, just to complete this soft skill section, so that right. If you read through the first line, to grow and develop as a software developer, you must accept and take ownership of your mistakes. That is what is accountability is all about. that is the main thing that I wanted to highlight in this all of these the slides that I talked about soft skills. uh, I mean, once you have that accountability, the mistakes or the errors that you made, and if you are ready to accept them and then get them corrected and then fix them and then move forward, that is where a successful software engineer comes out. Right. So this is again related to the same thing as I said. What do we expect from an intern? This is actually not. I'm not limiting to Wiley as what we are expecting the interns that we are going to hire. It's very general, right? So the first thing is analytical thinking. As I said in critical thinking part, so we have to be. We are looking for the interns to be, very analytical in their thinking, right? And attention to detail. This is a must. So when you are given a problem, when you are given a something to attend or kind of work to do, you have to have the attention to detail, because you need to look at what are all the details that is available, and what are the details that is not available but you can get through maybe research or asking a friend or asking a colleague. So and then if you have basic problem solving skills, right, at that point, with your analytical thinking, now you have all the details with you. And if you have a basic problem solve, those are like very basic, right? So I wanted to highlight the term basic here. It's not like rocket science, right? It's not very complex, but if you can apply your problem solving skill to here with all the details that you have right now, programming fundamentals you can always use. That is a given, right? Because I'm pretty sure you all have followed one or two or couple of many programming courses by now, and then you have that fundamental level of knowledge. So but what is most important is the first three: your analytical thinking ability, and then attention to detail, so that you won't miss any important information. And then you have the basic problem solving skills. So you know the programming fundamentals, you can apply them. You should be committed for the work, and the commitment is a must. And then at that point, pretty sure that you can be successful with the objective or the goal that you get as an intern from the industry. These are the there are a lot of things associated with this, like for example time management. I spoke about time management in soft skills. That is coming here as well. Like from an intern, we expect them to be very conscious on their time management. But I didn't want to add it here because those I already discussed, and as well as those are very basic things. I mean, for example, I can relate to that in if you actually attention to detail, what is the time that you have got for this particular task. So then what is the deadline, and then what are the things that you need to do. Those are everything is details, right? So if you know the details right, and then if you have them right with you, you simply can master the other soft skills along with them, and then can be a very successful software engineer in the future. Right. So I think, yeah, we have 10 more minutes. I will quickly go through the career hierarchy that you all will have once you join the Indian industry. So of course, as fresh graduate or maybe after your internship, you will start as an associate software engineer. Some places actually you can start as software engineers as well, but this is the very common ground that we have for fresh graduates to start with. That is actually put there. So associate software engineer means, I will not like going through the career hierarchy, but I will try to add some details as well, for you all to get an idea about what this role is particularly about. So associate software engineer means you are just a starter. So you have the fundamentals and basic knowledge of programming, but you need some guidance, right? Not only the requirement, but you need some guidance to how you are going to, because most probably you will get a existing product or a project, and then you will be part of that project, and then you will start working on that. So in that case, you will need some guidance. So that is where the ASC, associate software engineer, comes in. And then once you have some experience with that particular project or maybe a couple of products, now you become a software engineer, right? With the experience, maybe after 1 year or 1.5 years, or maybe 2 years, depending on your experience and depending on how you perform on that role, you will become software engineer. You will promoted to software engineer. That is where actually we are looking for kind of engineering skills, right? Not a developer or a programmer. I would like to call them as a software engineer, because you have to master your engineering skills, where your problem solving and analytical thinking and everything comes in very handy in this area, where you don't have the same guidance that you got as associate software engineer. But you can when you are given a requirement, you should be able to understand it, and then you should be able to apply the knowledge that you already have, and then try to solve that problem. So once you are doing that particular work with your colleagues, with your teammates for a few years with experience, you will become a senior software engineer, right? That means you can actually guide one or two people, right? Maybe you will get two of associate software engineers under you. It's not like they are directly reporting to you, because at the same time you and them, everybody have a manager or a team lead or whoever will be there as your reporting structure. But you will actually guiding or mentoring or supporting to the other colleagues, right? The peers. So that is where that is the expectation out of a senior software engineer. So you are good enough to complete whatever the task assigned to you, as well as you should be able to guide someone or maybe some more people. So then once you become a software engineer, so now you have two paths, right? You can be either a people person, where you are looking for to manage a team of people, right? Or either you can be a tech specialist, right? Because there are some like two types of people. Some people are actually they have leadership skills inside them, so that they can work as well as they can help others to work, and they can manage people. But some set of people are there, they actually can work very well, right? They can focus, and then once they are given a task, they are very comprehensively fill it up and complete the task. But they are not very good enough of managing people. In that case, we have two tracks, right? So if you are a very specialist kind of a model, if you are a person who wants to master your technical skills only, you can be a technical specialist track, right? Or if you are a people person, like if you want to manage people with a team, if you want to become a leader in the future, you can choose the technical lead track, right? It's either to technical specialist track or a technical lead track. So associate level, where you will be starting at after the senior software engineer. So then if you are a specialist, you will be a technical specialist, and then if you are a associate lead, then you will be a technical lead. That is over time. That at that point, if you are a technical lead, you will have a team under you, right? So maybe like 5 to 6 people, or maybe 10 people under you, and then you will be managing that team as a team lead. So as I said, if you are a technical specialist, you will be a senior technical specialist, but you are part of a team. You are working in a team, but you are not managing people. But if you are a lead, you will be senior now with the experience and over time, and then you will be managing the team as well, and then you will be a senior technical lead. So these two tracks actually, the first one is technical track, the second one is management track. So these two tracks will grow, and then continue to be the same in the same tracks, but in a different roles. So as I said, if you are a senior specialist, and then you will start architecting your applications. Maybe you will now with working with multiple teams, multiple applications at the same time, because you are well experienced enough. So in that case, you will be associate solution architect. But if you are a senior tech team lead, then you will become an engineering manager. Now you get most of the time you get multiple teams, because now you are a senior lead, and you are senior enough to manage one team. Now you can actually manage a couple of other teams as well. Then you will come to the engineering manager type, right? But at the same time, if you are a technical specialist person, you can be a solution architect. And then yeah, you will be promoted to solution architect. The associate manager will be promoted to engineering manager, and then the senior architect or a senior manager, and then eventually you will be a head of department. Either of these track, actually, end of the day, if you are an architect, and then if you are a senior solution architect, and then there are a lot of managers under you as well. And also, if you are managing multiple teams, so you can still be the head of department. But of course, the other track, the management track, is directly going to the head of department, because that is where the people management skills are coming come into play. In that case, the manager, senior manager, and then maybe you can be either chapter lead, depending on the organization. There are some position called chapter lead, where you have multiple chapters. If not, if it is one department, maybe software engineering, then you can be the head of department. So that is the career ladder that you have in the software engineering industry. You will start as an associate software engineer, first of all as an intern, and then associate software engineer, and senior engineer, and then you will choose whether to specialist track or a management track. Then you will be a specialist or a technical lead, and then senior lead or a senior specialist, and then manager or architect. After that, eventually it will be a head of department. So that is where I mean, that is the the areas and the career ladder that you have to climb up once you started, and once get hands on experience in this industry. I think that's pretty much it for me to cover for this session. Yes. So questions.
With that, another chapter of Guest Talk series organized by CSUP is over. Hope to see you all from the next session. Thank you for joining.